Hello everyone, and welcome back to another episode of Oceanus. The cleaning of ship hulls and propellers is an important aspect of maritime vessel maintenance. They are the parts that are actually below water, which is why they need more care. The biochemical corrosion of salty seawater causes great harm to them. Ships spend a considerable amount of time in the water, which means they're constantly exposed to various elements like salt water, marine growth, and debris. The whole bottom of the ship, which returns from a long voyage, looks like a huge settlement of a colony of algae, barnacles, and other marine organisms. In spite of the up-to-date means designed to protect the ship against fouling, damage is inevitable. Such outgrowth can be 500 millimeters in thickness and sometimes even more. The speed loss due to increased traction is 30% of the rated one. Here, with the fuel oil consumption increases by the same amount. The regular underwater cleaning of the ship makes it possible to restore the initial speed by 95 to 98%. And respectively to decrease the fuel oil cost, which, as a rule, account for almost half of the operating cost. It is also advisable to clean and polish the propellers. This is done to decrease cavitation, which destroys the surface of the propellers. That's why the ship's hull underwater cleaning, washing of the sea valve gratings, and other structural members are so demanded today all over the world. Most ships are put into dry docks when it comes time to clean their massive hulls. However, cleaning a ship in a dry dock incurs very high expenses. It generally costs $1.2 to $1.6 million to put a ship in dry dock, excluding business losses over the weeks it takes to finish the job. To avoid these losses, many ship owners decide to clean their hulls while it is still in water, using divers with specialized equipment to do the job. The scheduled underwater cleaning of the hull is very economically advantageous during the inter-docking period. For example, such measures can save up to 900 tons of fuel oil per year for a ship owner having a tanker with a 50-ton displacement. Underwater cleaning has even more advantages. As the ship's weight decreases, the vulnerability and speed increases. The surfaces become clean and are ready for inspections or repair works. Fuel oil consumption decreases, and ultimately the ship's total lifetime increases. Divers play a vital role in ensuring that ships maintain their optimal performance by carefully cleaning both the propellers and the hull. One of the oldest but most proven methods for ship hull cleaning is hydrodynamic cavitation. This method removes the fouling from the ship's surface, maintaining its varnish and paint coating. This method makes it possible to carry out underwater cleaning where it is impossible to do it by mechanical method. Hydrodynamic cavitation is effective where it is required cleaning of the vent distribution ducts, sea chest gratings, sea chests, valves, and so on. The hydrocavitation as technology goes back to its origins in 1894, and the copyright belongs to Froude, an English engineer. As a simple example of cavitation, when the steam pressure from normal boiling water is equalized with the environmental pressure, bubbles are formed that flow to the zone of high pressure. With this motion, the bubbles seem to slam, creating a strong shock wave. The principle of operation of the plant for the hydrocavitation cleaning is based on the strength of a high-impact jet, which is delivered under certain pressure. Steam gas bubbles collapse that are coming to the surface, which should be cleaned. This shock wave cleans the hull and other structures against rust and fouling. The underwater cleaning of the hull by means of the hydrocavitation plant removes all without exception types of fouling, rust, paint, and another advantage is that hydrocavitation equipment has absolute environmental safety. In order for the ship to run efficiently, the propeller needs to work at its maximum potential. It must be free from any additional substances that may collect on it. Since modern propellers are usually made from stainless steel, bronze, or nibral alloy, they are resistant to corrosion. Yet any growth from the aquatic environment such as slime, moss, or mussels that can grow in fresh water or barnacles from salt water must be cleaned off. A new or properly cleaned propeller goes a long way to preventing propeller unbalance. Muriatic acid is a cleansing agent commonly used to clean propellers, and it works great on rust. Methods of mechanical cleaning by means of the hydraulic metals is required in case of a heavy degree of fouling, as well as when the ships should be cleaned very quickly during the ship's stay at anchor or in port. The underwater cleaning by means of the hydraulic metals and by using the hydraulically driven brush machine is based on the action of the rotating machine, equipped with a special brush, and the brush, in its turn, is driven by the hydraulic motor. The coaxial hose supplies the hydraulic liquid from the pump station, arranged above the water. The special design of the brush makes it possible to fit tightly, like sticking to the surface being cleaned. Brush carts can clean both the horizontal and vertical surfaces and can also remove practically all existing types of fouling, including shell mollusks, algae, and barnacles. The propeller and hull's main coating is not subjected to the risk of damage, in spite of the rather powerful effect on the surface of the machine. This is owing to the special materials of which the brushes are made. The level of brush hardness is also selected depending on the type of fouling, so the varnish and paint coating is not practically damaged. Ship cleaning is a dangerous process for both divers and the structure of the ship. The dedication and expertise of the divers plays a crucial role in maintaining the efficiency and performance of these massive vessels. That's it. If you enjoyed this dive into maritime maintenance, be sure to give us a thumbs up and subscribe for more exciting content.